On the back side, plugging it into our calculator. Y equals sine x times cosine x plus sine x cosine x. And we're going to hit graph. We should still be on the same thing. You should still be radian mode. You should still be Zoom Trig. All that should stay the same. You need this worksheet, you need a calculator. And then we're going to write this equation. Now this, from the other side, I believe every single one started at 0, 1. So when we hit trace, are we at 0, 1? No, where are we? 0, 0. Which trig function starts at 0, 0 and then goes up? Is this going to be a sine function?
Yep.
Yes, it is. So, let's see if we trace and go over 1 period. Now we're not going all the way to top. We're going to where it starts, where it's 0 again. Okay? So we went up, down, up to 1 period. What is this 1 period? Which is pi. So 1 period is pi. Can we find out what b is? So ultimately, how many times does it repeat in 2 pi units? Now, which way do you like? I mean, I have done it and told you both ways.
I like when you count the.
You like to count. Now it's sine, and we're looking here. So it goes up, down, up. That's 1 term.
Oh, so true.
Okay. So then we went up, down, up. That's 2. So what is your b going to be?
2.
Yeah. What? Your calculator. What's going on with your calculator? Zoom 7. Your Zoom button is a great thing to have. A great thing to know what you're doing. And after you're done with, if you want go and need to graph something else, go back and hit Zoom Standard, which is Zoom 6. Okay? So, can everybody tell me what is the equation of letter, or 1a? Sine 2x. Everybody agree? Yes. All right, let's go ahead and plug in letter B. Letter B was, oh, I'm on the wrong side, was y equals sine x cosine x minus sine x cosine x. So it's the same thing. All we're changing is the addition and subtraction. So I'm going back to y equals and just going over, putting a subtraction there. So I'm going to graph it. These are much better when it's in color. I'm sorry if you have one that's not in color.
That's why I couldn't see. I was like,
Oh, I thought your calculator is broken.
You thought your calculator was broken.
Oh, I was like, it's not working.
If you don't have the color, it's really hard to see. Unless,
like impossible.
no. Unless you use a little bit of logic. Sine x, cosine x. Minus sine x, cosine x.
0.
What did we just do? We subtracted something from that.
It's not fun.
Y equals 0. That's an equation of a line that actually is the x-axis.
Oh my gosh, this is so easy. It's the same.
Okay, sometimes we have to use some of that, that thing above our chin, the big mass, our brain. Your brain, please. 2a. So it's sine 2x. Y equals sine 2x cosine x plus cosine 2x. Oh, I don't ever write it like this, but they do, so I will. The last one I did not write like this, but it doesn't matter because commutative property of multiplication. So I'm plugging this into my calculator. Y equals sine. There most definitely is a pattern. So if you saw with the plus cosine. So what kind of function is this? Where are we starting? It's a sine function. It starts at 0, 0. Now when I trace and go over, then I get to 1 period. I'm at that 2.09. Do you remember that number from yesterday? 2.09? No? You do remember that. Do you remember what it was? It had a 3 in it, yeah. So there's 2 periods. I'm at 4.18. How many periods? 3 periods. 3 rotations, 3 cycles. 1, 2, 3, until I get to 2 pi. So what's the equation of this line? What? Sine 3x. Can we go back and put in letter B? Y equals sine 2x cosine x minus cosine 2x sine x. We'll put that in our calculator. Doing a subtraction there. I'm going to graph it. When we trace it, it still starts at 0. And by the time I get to 1 period, where am I? I'm at 2 pi, so 1 period is 2 pi, so what's your equation of the line? Go. I'm going to leave you. We're not going to say it out loud just yet. Keep going.
So whenever you're looking, you start at this origin, you go there. Is that one here, or is this one?
Oh yeah, sorry. Do what?
When you get here, is that one here?
No, have you done a complete rotation? That's so when you get back to here, you go to complete rotation. Yeah, because it hasn't gone down and back up. So when you get to the spot that you started at.
Oh, okay.
I'm not taking it out. Can you make your generalizations? Go ahead and write your equations. Make your generalizations of what is happening for each one. And then we're going to write some equations. You have equations on here. It's not going to hurt you to write 2 more.
I always put them back.
I did have to go find it. I found it like when we were at the pep rally. The kid had borrowed it that period, and they left it on the table in the reading room. And I went down the hall, and the socks never explained to me. Just hold my pencil, but I can tell that's mine. Should put something girly on every pencil so kids don't want to steal it. The pink ribbon. Miss Davis has like little flower sticks on top of all hers. Then you can't use the eraser. Alright, has everybody written the generalization? Do what? Yeah. We're gonna summarize it all in some equations.
Okay, I understand what the truth is, but I don't understand why it works.
Well, we're gonna talk about that.
Okay.
Sometimes it's one of those things like those postulates in geometry. You just take them as true. But you have just done 8 problems on one side and 8 problems on the other side, and it's the same thing for every single one. Right? And you did 8 problems on that side, it's the same thing for all 8 of those. Now, front and back are different.
Okay.
Front and back are different.
For similar concepts, just I see.
Okay. Okay. What do you want to try? Put it in your theory. What is this thing going to be? And then check it. Why do you clear it out every time? That's going to take you forever.
This evidence, the snow didn't happen. It's so sad.
I knew that this week, now, from now to the end, it's going to be the longest week ever. I was just happy with 2 hours better than nothing.
Yeah.
Because if we had just gotten up this morning and been fine, and like come to school at regular time, that would have been even worse.
Yeah. At least I like did get to sleep.
Yeah. I ate and I was asleep. It was really good.
My kids were still awake within 10 minutes of me waking up. I usually wake them up at 6:30. Sawyer was awake in Garrett's room by 6:40. Why? Why? I don't understand this.
My body just like normally wakes up by itself at like 7:10, 7:50. Like, and like I'm fine with it. And I feel super rested. But like when I wake up to an alarm, I always get tired. Like when I wake up just by myself, I feel rested.
Why are you getting off? Were you subtracting? I went to bed about I never slept more than 3 of the 2. They were at me. And here they were. And my mom was like, what's 3? I was like, what?
Oh, that is not right.
So it coefficients, and when we're adding. All right, I think we all have come up with something. The back one is harder to understand.
In words.
Why? What do you say? What is yours?
I don't know.
Do you have an idea of what's gonna happen?
On what?
If I were to give you an equation like this, y equals sine 5x cosine 3x plus cosine 5x sine 3x. What's going to be your answer without plugging it in your calculator? Do you have an idea?
Yeah, but
I don't care the words. Words aren't.
Yeah,
Not
I just
okay
don't know
either.
my idea.
Okay.
Would it be sine 6?
Is it going to be sine 6? Is that what happened on all these? I like to look at the 3 and the 2.
Oh, you add them.
Is that?
Wait. No.
The 2 and the 1.
Oh, you add them.
You add them. And then you have a 2 and a 1, and you're going to.
So you add the coefficients.
You're simply adding the coefficients. If you have a sine cosine together, we are simply going to add the coefficients. Okay? But if you have an equation where it's subtraction, you're subtracting 3x plus cosine 5x sine 3x. I could have done a plus there, didn't I? Oh, knew that was gonna happen. And it happened again. Why? Eraser. Be small. There. If you're subtracting, it will be sine, and you will subtract the coefficients. Correct? Alright, so let's go ahead and try to figure out a formula for this. And it's different than the other sides. We're going to talk about both sides, and we're going to compare them. But in this case, they were all sine and a cosine, and a sine and a cosine. They were mixed together. Sine, cosine, cosine. Your A and B, I'm going to call this now an A and a B. Your A and your B have to be the same in both pieces. Okay? So now I'm going to use A's and B's in my formula, if that's okay. So whatever they are, they have to be the same with sine and cosine, sine and cosine. Okay? If we're adding, write it down. Y equals sine A cosine B plus cosine A sine B. That formula will always be sine A plus B. It will always be that way. So actually, I really don't like having a y equals, because I have an equals down here. You have a sine, cosine, sine A, cosine B, cosine A, sine B. You need this formula. So go ahead and write it down on this piece of paper. Okay, but can I go ahead with it? We will talk about the difference. This red box, you need that written down. That is your equation if you have a sine A and a cosine B. Now, granted, Ryan, a lot of times I write sine, cosine. But I will write this as sine B cosine A, which are the same thing. That's the way I remember it. That's the way I think it was taught to me. This book, this worksheet is key on the A, B, then A, then B. I remember sine, cosine go together with it for a sine function. Because both of them start with sine. That's the way I was taught and I remember it. But they're the same thing. If you saw when I plugged it in my calculator, I did sine first and then cosine because you did it this way, no matter what it is, it's going to be, and that probably needs to be in parentheses, that A plus B. Okay, so can we have an equation for a subtraction in the middle? If you have a sine A cosine B minus, then I'm going to write it so cosine A sine B, it will always equal what? Sine of A minus B. Two equations. And I'll tell you that I'll probably get my list. Oh, I need a plus or minus in the middle of it. So if I scroll down, I might even rewrite it like this. Sine A cosine B plus and a minus. And I will do it equals sine of A plus or minus B. So that means if I'm adding, I'm adding. If I'm subtracting, I'm subtracting. Okay? These will be things like if you, I've seen it once on an ACT where they put some type of function that was a sine and a sine or a cosine cosine, and they put something together like that that was one of these. I've only seen it once, so it's not very popular. But sine squared plus cosine squared equals 1 is on there almost every time. Ooh, fun. Not really, but there's like 3 trig questions. You got them. Okay. So what about the first side? The side, what was different about the equations on the front side? The first side we did yesterday. It was a cosine, but it was a cosine A and a cosine B. They were together, cosine, cosine. And plus a sine, sine. It was always what? And you said it was the opposite. It was an addition sign, then you were subtracting. But when they were together, what type of function was it? What was the function yesterday? It was cosine. And then we were subtracting them. So I always read cosine, cosine. It's a cosine function. It has to start with cosine, cosine. Okay? And then if we have a cosine minus sine, sine. Oops. Nobody sees what I just did. Because I jumped ahead already. Pretend that was actually started out to be a B. Equals cosine A plus B. Very, very important functions, important equations. Okay? That we'll use a lot, and we'll come up with a lot more stuff based on this. I have been the whole time. You have? Okay. Yes. Oh, okay. Well, we got about 3 more minutes. So, can I ask you a question? Yes. Why, when in the world might we ever want or need to use this? Not even on the ACT. What if I asked you to find the exact value of a degree that you don't have in your triangle? You can take.
Why would anyone ask me?
Because I might want to know, what is cosine of 15 degrees? Okay? How? And you can't put that in a triangle, can you? No. You only know which ones do you know in a triangle. 30, 45, 60, technically you know 90, and 0 on 180, yes. Okay? So you know about a handful of things. I'm going to give you the tools. Can you find cosine 15? Nope, I want an exact answer, meaning I want what in my answer?
Fractions.
Square roots.
That's what I meant.
Yes, all of that.
Good effort.
And plus, if you plugged it in, you plugged it in radians, which is probably wrong anyway. Oh, you already did? What's another way to write 15 degrees? Can I add something together or subtract something to get 15 degrees?
Yes.
Could I subtract
360.
5.
Could I subtract 60 minus 45? Oh, is 60 minus 45 15? Yes? So, do we now have a formula for an A minus B? A cosine A minus B.
This is too much. Wait, but you have to. Don't you have to do the next one?
The what?
Like you only have half of it. I'll do
No, okay, so this piece right here
Oh, it's the end piece.
is this piece.
Oh.
So I'm going to go backwards and write that.
How do you know that?
So this is my A, 60 is my A, B is 45. So I'm going to put everywhere I see an A, I'm going to put a 60.
Oh, that's.
Everywhere I see a B, I'm going to put a 45.
Oh boy.
So here we go. If you want to write, it's cosine 60.
Oh, I can do that.
Yes, you can. Cosine 45. There's a subtraction, so I'm going to add
Oh.
sine 60, sine 45. Now, each individual piece, you can have an answer for, yes? So what's cosine 60? I'm drawing a triangle, 30, 60, 1, 2, square root of 3. Cosine 60, adjacent over hypotenuse. Cosine 45, I'm going to give you a little hint, it's square root of 2 over 2. Plus, what's sine 60? Square root of 3 over 2. What is sine 45? Now, they all have the same denominators, but before we can add, do we need to multiply fractions?
Yeah.
Square root of 2 over 4 plus, how do you multiply square root of 3 times square root of 2?
36.
Square root of 6, you're going to multiply those. Square root of 6 over 4.
That's the answer.
Square root, no.
Square root of 2 plus square root of 6 over 4.
You cannot add them. That is the exact answer.
So how?
We don't put them in your calculators.
What's the answer?
That's it. That's your answer.